This is a solution video to question 16, paper 2 of the TMUA 2020 exam. So in this question, we're given the fundamental theorem of calculus and we're stated what it is here. So it's just saying that if you differentiate with respect to x the integral from 0 to x of f of t dt, you end up with f of x again. And then we're told that a student is trying to calculate what this is. So this is slightly different from the fundamental theorem of calculus because we've got the integral from x to 2x of t squared dt. And we're given a bunch of steps that the student tried to take, and we want to figure out whether his calculation is correct or incorrect, and if it is incorrect, where does the first mistake happen? So I think the strategy here would be to try and look at each step one by one and check whether each of them are correct. And then, if by the end of it we found no mistakes, then that would mean that the calculation was actually correct. So let's first look at step 1. So step 1 is just looking at splitting this integral in terms of the integral from 0 to x and the integral from 0 to the integral from 0 to 2x and the integral from 0 to x. So it's just saying that the integral from x to 2x of something is the same as taking the integral from 0 to 2x minus the integral from 0 to x. And this is true because what this line is saying, okay, take everything from 0 to x and then remove everything that you had before x. So this line is correct. Next, if we look at the second step is just saying, okay, whether this line follows by the fundamental theorem of calculus. If we look what the fundamental theorem of calculus says, then it's saying this line here is the same as this line with f of t replaced by t squared. So this line here then would just be should just equal to f of x, which is just x squared. So this is correct. Next, as we look at the third step, this third step is talking about doing the same thing, but with the integral from 0 to 2x and claiming that this is equal to 4x squared using FTC. Now, the statement FTC has nothing to do with 2x, it just has x on top. So we have to check this separately. So if we do this separately, so manually, so integrate first t squared from 0 to 2x, we're going to get t cubed over 3 and then 0 to 2x as the limits. And that gives us 8x cubed over 3. And when we differentiate that, we're going to get 8x squared, which is not the 4x squared they claimed here. So that means this step is incorrect. So that means our answer is D because we've identified a mistake. And the first mistake we identified was in 3. So the calculation is incorrect and the first mistake happens in 3.